Okay, we look at this problem and you're probably like, why are you wasting my time with this? Let's do it in a calculator. We need to see the process. We need to see the process, definitely, because of what's about to happen. If we don't have a frame of reference for a process that we learned years ago, if you learned this process, and some of you might have learned the division process differently, but if you don't have this frame of reference, then things won't make sense moving forward. So let's delve into something you have seen before, hopefully. 8 goes into 5,141 how many times? And the way that I learned it and the way that some of you may have learned it is going to look like this. And I'm going to switch colors a lot in this process just so things don't all run together completely. Does 8 go into 5? No. Does 8 go into 51? Yes, it does. So we're just going to take this as much as we can. So 8 doesn't go into 5, 8 does go into 51. 8 goes into 51 6 times. And then at this point, what I'm going to do is say, well, 6 times 8 is 48. And if you're like, oh my goodness, I've seen this, I know how to do it. Trust me, this process is going to help us as we move into the next step. So let's switch back to black. There we go. And what we're going to do at this point is subtract. So this is going to come in handy if I change signs, and that will really come in handy with variables. You'll see how this works. So 51. Ignore the 41. 51 minus 48 is going to give me 3. Not a red 3. It's going to give me 3. And then I'm going to just bring down the 4 and the 1. You can actually just bring down the 4 if you would like. Or you could just drag the whole thing down. You could bring down, there we go. We're going to bring down the 4. Let's not bring down the 1. Some people do. I don't. 8 goes into 34. Okay, well, 8 goes into 32. 4 times, so we're going to put a 4 up here. 8 goes into 32 4 times. This thing drags one more time, I might punch it. 4 times 8 is 32. I'm careful that I don't drag it because then I have to like follow through with my word and like punch this TV, and it's, you know, not very good to do that. So we're going to subtract, and let's draw this little line right here. And we're going to do 34 minus 32, and that's going to give me 2. We're going to bring down this 1. So 8 goes into 21. Well, not an even number of times. Well, not without a remainder. So 8 goes into 21, 2 times. And we're putting some things in blue, like every other line seems to be in blue. So 2 times 8 is 16. And that means that we will subtract at this point. So I'm going to use my red subtraction. There it is. I wish this thing would stay for once. And then we have a 5. And then you could go further with decimals. You could totally go further with decimals and be like, oh yeah, let's use decimals. I'm not, because you put like a 0.0 and keep going. Lovely, let's not. 5 is my remainder. And so what I really have as a final answer is 642 and 5/8. If you write it as a mixed number. Okay, it's kind of an odd mixed number. Well, that part's even. No, but this number is a little bit different than what we're used to looking at in terms of mixed numbers. Usually they're much smaller, but 642 and 5/8. Now, another way you could think about it is that it is 642 plus 5/8. Just saying, these are the same thing. Same idea, different representation. Okay, what was that all about? Let's look at the next problem. You'll see this process is going to come in handy. Let's actually drag it this way on purpose. There we go. And we're going to write the next problem. And the next problem is written like this. X squared plus 10x plus 16. Well, 16 is dragging there. There we go. Divided by x plus 2. So we're going to write this the same way we want. And we're going to have, well, x plus 2. And it's going to go into x squared plus 10x plus 16. Okay. Oh boy. We're going to use this as a guide to help us with that. Let's separate the two. There we go. And we will start with blue. Okay. You might look at this and say, how many times does x plus 2 go into x squared? And things get all confusing. We're just going to deal with the first term here and the first term there. So how many times does x go into x squared? In other words, if I said, what's x squared divided by x? It would be x. What's x squared divided by x? It would be x. And then we're going to multiply. Just like you did 6 times 8 and got 48, we're going to do x times x, and we're going to get x squared. And then we're going to do x times 2, and we're going to get 2x. And then we're going to switch colors. Draw this line right here. And we're going to subtract. Now what about the 16? He'll wait. He'll just wait his turn. Just like a good constant should. We're going to subtract this entire thing, which really means I'm going to change both signs. If they were negative, I'd change them to positive. And at this point, we will, well, change your signs and add them. So x squared minus x squared is 0. Mission accomplished on that. 10x minus 2x is 8x. Let's bring down the 16, plus 16. And now we're going to do the same process again. How many times does first thing here go into first thing here? First term into first term. So if I were to word this differently, I would really say, what's 8x divided by x? And you can just cancel your x's and you'd get 8. So I'm about to put an 8 up here. Now there are other people that will explain this, and they will shift these numbers over into a different location just based on place value. This is the best way I know to explain it. Okay, so if you're looking at this, you're comparing it to someone else, and they're like, well, they put their x over here. Yeah, I don't. X plus 8. There we go. 8 times x is 8x. Hey, they're the same. They better be. They better be. It was engineered that way. 8 times 2 is 16. And we are going to draw the line. And we're going to subtract. And you can see where this is going. When we subtract, we're going to basically like change our signs. And when we add those, we will have a remainder of 0. So our final answer on this one was 642 and 5/8. Notice where I was pointing. 642 and 5/8. This one, I'm dropping the marker. This one's going to be, and let's erase a little bit here. This one's going to be, I'm stalling. There we go. X plus 8, and don't write this next part. 0 over x plus 2. But because it's 0, we don't have to write that part. So the real answer, well, the actual answer that we would write in a practical sense is x plus 8. Okay, that takes us through the first 2 long division problems. There's one more we're going to do where things get just a little bit trickier. Same kind of structure. Slide this up. There we go. Yep, we're writing in the correct color. And this problem is 8x cubed plus 729 over, this one's delicious, you're going to love it, 2x plus 9. And I'm tempted to go ahead and blurt out the answer. May I? Yeah, let's do it. The final answer is, and I'm going to show you where this comes from in a minute, 4x squared plus 18x plus 81. Okay? I'm going to show you how we got that in a second. I want you to hold that in your head. You'll see the answer again in a minute, but there's a teaser coming. All right, this is written with a fraction in terms of division, so we're going to write it the division way that we have written the other two. So let's do 2x plus 9, and it's going to go into 8x cubed plus 729. And when I do that, hold this thought for a second. If I just wrote 8x cubed plus 729, that's fantastic, but I'm missing some stuff. So let's scroll down for a second. If I had, for example, 5,041 instead of 5141, and I divided that by 8, then I better put a 0 right there, right? Zeros are placeholders when you're dealing with place value. So I didn't have anything missing here that I needed a 0 to hold its place, but I do here. So what I'm really dealing with is 8x cubed. I have no squared term. I have no quadratic term. I have no linear term, and I do have a constant term. I need zeros as placeholders. You have to have them. If you don't do it, then you're going to run into a lot of misalignment. If you're that far ahead and you're thinking you can, but don't. All right, lots of color switching, but we're going to do it. Makes it easier if we can kind of visualize it that way. So first thing here into first thing here. First term into first term. How many times does 2x go into 8x cubed? Think about it this way if you like. That's really asking what's 8x cubed divided by 2x. 8 divided by 2 is 4. X cubed divided by x is x squared. That gives me 4x squared. Okay, 4x squared times 2x is going to give me 8x cubed. Oh, they're the same. They better be. We engineered it that way. 4x squared times 9 is 36x squared. They are not the same, and that's okay. All right, let's drop. Whoa, that happened again. You know what happens now. All right, what we're going to do is change our signs and add them. So change sign, and we'll bring down that 0x in just a second. Do I need the 0x? It's a good placeholder. It's easy to lose your place if you don't put it. So switching to black, there we go. 0, those go away. Let's not write that one because it would just be like a 0 in the front. Like, oh, what do I need it for? A 0 in the front, yeah, don't need it. 0 minus 36, negative 36x squared. And then, ooh, that's an odd x squared. Odd looking x squared. Not to body shame this x squared, but it just looks weird. All right, so we have that. And if you want to bring that one down, you can. I'm not. And so now we will switch colors again because my answer is in blue. Every other line is in blue. That's just how I do it. 2x goes into negative 36x squared. That's another way of asking this. If I divide, whoops, that's squared. I'm having a hard time with those squares, I tell you what. Negative 36 divided by 2 is negative 18. X squared divided by x is x. I have negative 18x. That's going to go right here. And now we're going to start multiplying. Negative 18x squared times 2x is negative 36x squared. Negative 18x squared times 8. Times 9, sorry, that would be a number, 162. So minus 162x. 18 times 8 is 162. So what we're going to do now is draw the line, bring that down, and we're going to change some signs because we're subtracting, right? So when you subtract, you're really changing the sign and adding. So what was negative is now positive. Do it again, see what happens. What was negative is now positive, and those cancel, become 0. These become 0 plus 162x, so it's 162x, pardon the bad handwriting, plus 729. The numbers are getting ridiculous, but it's going to work. Watch this. Okay, switching colors. 2 goes into 162 81 times. 81 times 2 is 162. 81 times 9 is probably not something you know off the top of your head, but you do, because it's 9 times 9 times 9. It's 9 cubed. Hold that thought too. That's 729. We'll draw the line here. We'll change the signs. And when we do, we have 0 as our remainder. All right, that means my final answer, final answer is this up here. I will write it in red. A little inconsistent with the way I've done the other ones, but it's 4x squared minus 18x. Whoops, that should just be 18x. Oops. Yep, I'm going to have to change that. My bad. There we go. 18x. Yep. Sorry about that. And 81. And I want to go back to where that took place. I had negative 18x here, but I accidentally put 18x squared. And it came from me saying how many times does 2x go into negative 36x squared, and I got a little carried away. I apologize. Make sure you make that correction as well. If you've been dying on the inside this entire time, I'm sorry. But this is my final answer. Do you want to know how we knew that from the very beginning? Because this one's an exception. This is an exception and an exceptional problem. Okay, I want to work this one out. This is extra on the video. If you got it and you're good, fine. But if you want to hear about the difference, or sum, in this case, of cubes, and I hope you do, then hang around. I'll try to keep this about 45 seconds or less. The original problem, no guarantees on that. The original problem was x cubed plus 729 divided by some stuff. We'll take care of that division in a second. This is really 2x all cubed plus 9 cubed. This is the sum of cubes, and we'll use our sum of cubes formula, which makes this 2x 9, 2x all squared, so 4x squared. 2x times 9 is 18x. That should not be a plus, that should be a minus. We'll take care of that in a second. And 9 squared, which would be 81. This is, again, we're dealing with the sum of cubes. I'm following that formula, the a cubed plus b cubed, a plus b, and then a squared minus ab plus b squared. Sounds overwhelming, but you've seen it before. Same sign, opposite sign, always positive. This was somewhat the original problem. Let's finish writing what the problem actually was. It's 2x plus 9. This 2x plus 9 in the bottom, 2x plus 9 in the denominator. And then if we were to cancel out factors, we would have, boom, there it is right there.